Good day. We'll discuss solving word problems on rational inequalities. Example 1. A box with a square base is to have a volume of 8 cubic meters. Let x be the length of the side of the square base and h be the height of the box. What are the possible measurements of a side of the square base if the height should be longer than a side of the square base? So in order for us to solve this problem, we should create first a rational inequality. But first, let's analyze the problem. So according to the problem, let x be the length of the side of the square base and h the height of the box. Now, the volume of a rectangular box is the product of its width, length, and height. That is, length times width times height. That is the volume. But since the base of the box is square, its length and width are equal. So according to the problem, it's x. That's the side of the square. So length is x, width is x, times the height h. So that is why we have volume is equal to x squared h. Since the volume is 8 cubic meters given on the problem, so we have 8 is equal to x squared times h. So pure substitution. Next, since the height is greater than the width, the inequality therefore is h is greater than x. Okay, from here, we have 8 is equal to x squared h. Now, to solve for h, we can divide both sides by x squared. Okay, so cancel. So therefore, we have h is equal to 8 over x squared. Given, of course, that x must not be 0. Okay, x must not be 0 because if it's 0, it is undefined. Okay, so take note, h is equal to 8 over x squared. So going back, since the height is greater than the width, the inequality, or this width is the a side of the square base, no, the side of a square base. So the inequality therefore is h is greater than x because of this, greater than the width. Or you can have also the length, but still it's x because it's a square base. But h is equal to 8 over x squared from the previous slide. Okay, so this is therefore our inequality. And then we'll apply now the rules or the steps in finding the solutions for our x. So we will now solve the inequality. So of course, we need to transpose. And then the LCD is x squared. So we have 8 minus x times x squared all over x squared. So which is greater than 0. So remove the parentheses, we have 8 minus x cubed over x squared. So this is now the end of step number 1. One single rational expression on the left and 0 on the right. The next step is to find the zeros and the undefined, so the numerator and denominator. So the zeros of the numerator, we have 8 minus x cubed is equal to 0. I can transpose x cubed. So we have 8 is equal to positive x cubed. And then the cube root of 8 is 2 and the cube root of x cubed is 3. Take note that 8 is equal to 2 cubed. And taking the cube root of this, we can cancel the exponent 3. So that is why it's equal to 2. The same is true with the x cubed. Okay, taking the cube root, we can cancel the exponent and the index. So we have this is equal to x. So that is why we have x is equal to 2. Now for the denominator, we have x squared equals 0. So taking the square root, just take the square root on both sides. So we have x is equal to 0. Okay, so therefore we have this on the number line. We have negative infinity here. Then we have 0, and we have 2, and we have positive infinity. Of course, since our inequality is greater than, so all of the intervals use the parenthesis. So parenthesis. So therefore, we have these intervals, negative infinity to 0, then 0 to 2, and 2 to positive infinity. So we have here. So lahat parenthesis. So from negative infinity to 0, 0 to 2, and 2 to infinity. Test points. So I can have negative 1, I can have 1, and I can have 3. Okay, by substitution, we will arrive at these signs. Plus, 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 minus, plus. Okay, and then here at the bottom, we only need to divide the numerator and the denominator. So positive divided by positive is positive. Positive divided by positive is positive. Then last, negative divided by positive is negative. So we will choose plus since our inequality uses the greater than 0. So it points to the positive number. So hence, we will have these two. 0, negative 0, negative infinity to 0, union 0 to 2. Okay, but we're talking about length here. So there is no negative length, right? So we can delete this. We will not accept this answer because there's no such thing as negative length. So we will only accept this interval 0 to 2. So we conclude that the possible measurements of the side of the square should be less than 2 meters because we have this interval from 0 to 2 exclusive. Okay, next. A dressmaker ordered several meters of red cloth from a vendor, but the vendor only had 4 meters of red cloth in stock. The vendor bought the remaining lengths of red cloth from a wholesaler for 1,120 pesos. He then sold those lengths of red cloth to the dressmaker, along with the original 4 meters of cloth, for a total of 1,600 pesos. If the vendor's price per meter is at least 10 pesos more than the wholesaler's price per meter, what is the possible length of cloth did the vendor purchase from the wholesaler? So let the variable x be the length of the additional cloth purchased by the vendor from the wholesaler. So this is the additional cloth because the vendor only had 4 meters. So that's why the vendor bought another uh, a length or additional cloth. So he purchased it from the wholesaler. So let put that let's put that as the variable x, and we'll consider this table. So the wholesaler has x meters of red cloth. Okay, so this is the additional cloth the vendor bought from the wholesaler. So the vendor now has x plus 4 because he had 4 meters. So 4 meters plus the additional red cloth from the wholesaler, which is x. So we have x plus 4. Now, the price for the wholesaler, this red cloth is 1,120. Okay, from the problem. The remaining length, so this is the additional length, so that is x. The price is 1,120. And then the vendor sold this one with 4 meters of cloth to a total of 1,600. So the price is 1,600. Of course, it is much expensive because we have an additional 4 meters of red cloth. Okay, now, at the end of this statement or of this problem, we are comparing the price per meter. Okay, so that is why on the last column, I included here the price per meter. So the price per meter, when we say per, that is division, right? So the price, 1,120 divided by X, okay, per meter, that is the red cloth, the length of the red cloth. And for the vendor, we have 1,600 divided by X plus 4. Okay, so we have this. Now on this statement, the vendor's price, so a vendor's price, this one, is at least, when we say at least, it is greater than or equal. So the vendor's price is at least the wholesaler's price more than 10 pesos. So 10 pesos more than the wholesaler's price. So this must be our inequality. Okay, so we have here, this is the vendor's price, at least, so greater than or equal the wholesaler's price plus 10. Okay, since the vendor's price per meter is at least 10 pesos more than the wholesaler's price. This is the wholesaler's price. So 10 pesos more than the wholesaler's price. So therefore, this is now our rational inequality. And we're now ready to follow the steps. So we will transpose everything to the left. So we have negative 1,120 over x minus 10. And then the LCD is x times x plus 4. So we have here 1,600x minus 1,120 times x plus 4 minus 10x times x plus 4. So how did we get that? Okay, so for the numerator only, you may apply the uh, strategy in rational equation. So our LCD is x times x plus 4. Okay, so if we multiply this to 1,600 over x plus 4, we can cancel x plus 4. Okay, so that is why we're left with 1,600 times x. So that is why we have here. Okay, next, if we multiply x times x plus 4 to 1,120 over x, so we can cancel x. That is why we're left with 1,120 times x plus 4. And of course, it is minus because of this, so minus. And last, of course, so we cannot cancel anything because 10 has no denominator, so times 10. So we can just multiply them. 10x times x plus 4. Okay, I hope that's clear. Next, of course, is to distribute to remove the grouping symbol on the numerator. So we have 1,120x minus 4,480 kasi negative times positive is negative. And then on this side, we have negative 10x times x. We have negative 10x squared. Negative 10x times positive 4 is negative 40x. Okay, and then we combine like terms. So there's only one negative 10x squared. So I put it here at the start. And then 1,600x minus 1,120x minus 40x is equal to positive 440x. And then copy minus 4,480. So this is now our rational inequality, or the end of step number 1. Okay, after this, we'll solve the numerator and denominator. I can factor out negative 10. Okay, so we have negative 10x squared minus or plus 440x minus 4480. So if I factor out 10, negative 10, so it means that I will divide everything by negative 10. Okay, so 440x divided by negative 10 and negative 4480 divided by negative 10. Okay, so negative 10 divided by negative, I can cancel this. That's why we have x squared Positive divided by negative is negative. So 440 divided by 10 is 44. Negative, negative, so it's positive. So by the way, there's x here. Then 480 divided by 10, of course, is 448. So, okay, that is why we have this expression. Okay, negative 10 times the quantity, x squared minus 44x plus 448. Then I can divide both sides by negative 10. No, divide both sides by negative 10. So negative 10, so it means I can cancel negative 10. Negative 10, 0 divided by negative 10 is 0. So that is why we're left with x squared minus 44x plus 48. And we can factor this, x minus 16 times x minus 28. So this means that either this is 0 or this is 0. So x minus 16 equals 0 means x equals 16, or x minus 28 equals 0, or x equals 28. So that is for the numerator. Now for the denominator, we have x equals 0 or x plus 4 equals 0 because our denominator is x times x plus 4. Okay, so we have x equals 0 and x plus 4 equals 0. So we have x equals negative 4. So therefore, our numerator, we have 2, 16, and 28. Our denominator, we have negative 4 and 0. Our inequality is greater than or equal, so it's here. So we will use bracket on the numerator. So we have negative infinity, we have negative 4, we have 0, we have 16, and 28. So meaning, again, this is bracket because we have greater than or equal. And the numerator only ang mag-bracket. So for the denominator, we cannot include these values, no? So parentheses. So that is why we have these 5 intervals. So I can have test points negative 5, negative 1, 1, 20, and 30. Okay, substituting these values on this numerator and denominator, we have these signs. These are the signs, the minus and plus signs. Now at the bottom, again, numerator divided by the denominator. Negative divided by positive is negative. Negative divided by negative is positive. Negative divided by positive is negative. Positive divided by positive is positive. Negative divided by positive is negative. Okay, choose plus since the inequality is greater than or equal to 0. So we have here. So therefore, we have negative 4 to 0 union 16 to 28. Again, this is about length, so there is no such thing as negative length. So we will reject this answer, and we will only accept 16 to 28. Therefore, we conclude that the possible length of cloth that the vendor purchased from the wholesaler is between 16 meters and 28 meters inclusive. It means that 16 and 28 are included in the interval. Okay, and last example. The function c of x equals 10x plus 3000 represents the cost to produce x number of items. How many items should be produced so that the average cost is less than $40? So the average cost, of course, now when we say average, is given by c of x, the function, divided by the number of items. Okay, the number of items. So that is the average cost. So it is given that c of x is 10x plus 3000. So we have this as the average cost. Now we must find the number of items such that the average cost is less than 40. So meaning, this is the average cost less than 40. So therefore, this is now our rational inequality because c of x is again 10x plus 300. Okay, so this is our rational inequality. And now we're ready to solve for the inequality. Transpose 40, so we have negative 40. And then we can have this. Okay, 10x plus 3000 minus 40x divided by x. Okay, we can have cross multiplication. This is over 1. So 40x. 40 times x. Again, do not delete the denominator or the LCD. So combine negative 40x plus 10x, we have negative 30x. So therefore, this is now the end of step number 1. Now let's go to step number 2. So I can transpose negative 30x. So we have positive 30x. And then divide both sides by 30. Okay, divide both sides by 30. So that is x is equal to 100. And for the denominator, of course, it's x. So we have x equals 0. So we have here for the intervals, we have negative infinity, we have 0 and 100, and we have positive infinity. So since this is less than, so all of the intervals uses the parenthesis. So parenthesis. So that is why we have here negative infinity to 0, 0 to 100, and 100 to positive infinity. Okay, so I can have these test points, negative 1, 1, and 101. Again, substituting these test points, we have these signs. Okay, and for at the bottom, we have positive divided by negative is negative, positive divided by positive is positive, negative divided by positive is negative. So since our inequality is less than 0, so pointing to the negative numbers, so we will choose the negative sign. So hence, we have negative infinity to 0, union 100 to positive infinity. But there is no negative number of items. Okay, so there is no negative number of items. So therefore, we will not accept negative infinity to 0. Okay, we will only accept this. So we conclude that more than, okay, this is deleted, so that more than 100 items must be produced to keep the average cost below $40. Diba? When we say 100 to infinity, it means more than 100 items. So we mean that, again, more than 100 items must be produced to keep the average cost below $40. Okay, thank you for listening.